Alright guys, welcome back. It's been a while since I did a video, but I had a request to come in, so here's the request. The individual asked me to work this problem. It's basically how many phosphorus atoms are in 31.0 grams of calcium phosphate. Now this problem has a lot going on. It has so much going on that it's more than just one simple problem. First of all, we got to figure out the formula for calcium phosphate. Then once we do that, we'll have to even calculate its molar mass, because in this problem they ask for how many atoms, but they gave us grams, so we're going to have to calculate mass, molar mass. So I have a periodic table sheet on hand so we can do this. After that, we'll be using Avogadro's number, the 6.02 times 10 to the 23rd, for the use of atoms here. So let's go ahead and get started. The first thing we need to do is figure out what formula calcium phosphate is. Well, as you remember from earlier videos, calcium as an ion is Ca plus 2. Phosphate as an ion, notice it ends in Ate. That comes from the polyatomic ion list, and it is on the back of the periodic table that I provide you from my website. Phosphate is PO4 negative 3. It's right here, PO4 negative 3. Just in case you can't see it, I'll zoom in just a little bit so you can see a little bit better. There it is, phosphate, PO4 negative 3. So let's go back and I'll write that down. Phosphate is PO4 negative 3. So when we get ready to write this, now if you need more review over this, how to get these ions to write the formula, you can watch the video on writing and naming ionic compounds and metallic compounds. So anyway, the formula for calcium phosphate is Ca3PO4 in a set of parentheses. Now the reason why this PO4 is going into a set of parentheses is we're bringing a number down as a subscript. Now if we brought a number down such as 1, we wouldn't need these parentheses, but I need the parentheses because I'm bringing this 2 down behind the 4, and this 3 is the one that went down behind the Ca, so this 2 goes behind here. So there's the formula for calcium phosphate. Now we're almost ready to begin, but I'm going to go ahead and calculate the molar mass of calcium phosphate because the given problem mentioned grams. So I need to do that. So let's make a little grocery list for the Ca3PO4, basically keeping track of every atom that's involved. We've got Ca, we have P, and we have O. Now looking at this, you'll see that calcium, we have 3 calciums. Okay, there's a little 3 here that goes to the Ca, so we know we have 3 calciums involved. On the P's, we have a 1P here. You know, there's only 1P, but it's being multiplied by 2, so we have 2 phosphorus atoms there, okay, that we need to weigh. Here we have 8 oxygen atoms. Now that's it for counting them up, but I need to calculate the molar mass. Okay, so I'm going to use the periodic table to get the values of these. Now Ca, calcium, is in the second column on the periodic table. If you notice, it's right here. The atomic mass of calcium is 40.08, so let's write that down. 40.08. 40.08. Now if your periodic table has a different value, that's okay. It's just the one that I gave my students went out to the nearest hundreds. It rounded them all to the nearest hundred. Alright, phosphorus. If you look at phosphorus, phosphorus is in column 15. Notice it has an atomic mass of 30.97. So let's write that down. 30.97. 30.97. Hey, I'm doing this with a mouse, so this isn't too bad. Okay, oxygen, I think on this is 16. Yes, it's 16 on mine. Now yours might be like 15.99 or 15.998, but just use the one that's on your periodic table. Mine, it goes out to the nearest hundredth, so that's what I'm going to use, 16.00. Okay, so let's go back, write this down, 16.00. Now, what we will do is we will punch this into a calculator. I've got one right here. I've got my TI-83, virtual TI-83, and I'm going to do the math on this and write the molar mass down here. Okay, I have 3 times 40. Whoops, I don't need that. 3 times 40.08 plus 2 times 30.97 plus 8 times 16.00. The 0.00 is not necessary, but it's there. Now, there's the 3 times 40.08 plus 2 times 30.97 plus 8 times 16, which is, all this gives me 310.18. Now that's my molar mass, 310.18. Now I'm going to make sure I wrote that down. I said it, but I want to make sure that's what it was on the calculator. 310.18, and it was. Now, since this is molar mass, technically we should write grams per mole. That way, that's a reminder that, hey, this is molar mass. I've seen some people not even bother to write it, but so far we've got everything we need to work this problem, so let's get at it. Okay. First thing we're going to do is write down 31.0 grams of the Ca3 parentheses PO4 close parentheses 2, and that's my given amount. And I'm going to put this over 1. Now, next, what I'll do is draw my line out straight again. Now, since this is grams of Ca3PO42, down here is grams of Ca3PO42. So I'm going to write the molar mass down here. So here I'm going to write 310.18. Remember, that's grams of the Ca3 PO4 close parentheses 2. Up on top, I'm going to write the 1 mole. Now, if you're wondering where the 1 mole came from, the 1 mole came from the units of grams per mole. It floated up to the top. Moles of Ca3 parentheses PO4 2. Okay. Now, after this, I will need to pay attention to what's left over. I've got moles of Ca3PO4 2. I need to get to moles of phosphorus. Well, I can only do that by using this formula here. I know that in 1 mole of the Ca3 PO42 whoops, sorry that the 4 is so ugly. I'll just do it like that. That way you won't be able to tell. In 1 mole of Ca3PO42, I know that there are 2 moles of phosphorus. I know there's 2 because this 2 times P is 2P times this 1 in the front. So I know there's 2 moles of phosphorus atoms. Okay. Now, they want to know how many P atoms there are. How many P atoms. So I'm forced to keep going here. So down here I'll write down 1 mole. In 1 mole of what? Well, in this case it would be phosphorus. In 1 mole of phosphorus, I know that there are 6.02 times 10. Wow, I'm running out of room. Times 10 to the 23rd atoms. And this is for atoms of phosphorus. I don't know if I can squeeze that in there. Let me stretch a little bit more, get some more room here. Atoms. Because there's always that many atoms in 1 mole. Atoms. Man, I need to stretch some more. Atoms of phosphorus. Now I'm assuming that this is the question that the person wrote to me, because it just says how many phosphorus atoms. Now if they just wanted how many moles of phosphorus atoms, I could have stopped right here at the 2p, and that would have been 2 moles of phosphorus atoms. But in the question here, it just says how many phosphorus atoms are there. So to me, that tells me that we need to continue the problem all the way out, because it just says how many phosphorus atoms. So to me, this is what the question is asking. Now if they would have said how many moles of phosphorus atoms, I would have stopped at the moles, at the 2 moles of phosphorus. But since it just says how many phosphorus atoms, I would continue to use all the way out to the 6.02 times 10 to the 23rd atoms here. Now what we need to do now is actually punch this into the calculator. So let me change my zoom factor to maybe 90% so we can see the problem all at once. So just like that. I had to zoom out so we can see it. But anyway, what we're going to do now is punch this in the calculator and see what we get. Alright, now remember, you can just punch in the top numbers all at once. 31.0 times 1, which I'm not going to waste my time, times 2, whoops, sorry, the calculator's going crazy, times 2, times 6.02, times 10. Now remember, times 10, you hit second comma, times 10 to the 23rd. Press enter. Now that's the top number. Now on the bottom, I've got to divide by 310.18, and that's the only denominator I have other than ones. So I'm actually finished with the denominator. So I'm going to press enter. Now this is my answer. Now as far as sig figs go, in the beginning of the problem, sorry my calculator's dancing around again. In the beginning problem I only had 3 sig figs. So this answer is only going to have 3 sig figs. So I'll move this over. I'm going to write for my answer 1.20 times 10, and the power that was shown on the calculator was times 10 to the 23rd. Now, if you're wondering how in the world is this 3 sig figs, remember that a trailing 0 behind the decimal with a number that's somewhere towards the front of it is significant. So basically this 0 here is significant. Look to the right here. This 3 is not big enough to push this 0 to a 1, so it stays a 0. So the 1.20 times 10 to the 23rd is correct with 3 sig figs, and this would be atoms of phosphorus. Now, I hope that this request problem suits your needs, the person that asked for it, and I hope that anyone else that is looking that needs an example of one of these worked, that this will also help you. Anyway, y'all have a good night, and I hope you enjoy it.